Methods of expressing concentration of solution, Part 1. Some terminologies: that a solution is a homogeneous mixture composed of two or more components. Okay, and a standard solution, it is a solution of known concentration. This is used in various analytical procedures. And concentration refers to the amount of a given substance present in a solution, referring very often to homogeneous solution. Now, these are various ways of expressing concentration of solution. P percent concentration, okay, or this is also called part per hundred, part per million, part per billion, molarity, normality, molality, and formality. This presentation will cover all except normality. Normality will be given in the succeeding video. Percent concentration, okay, as I was saying earlier, parts per hundred. This can be expressed in terms of mass of solute per mass of solution, or by volume, volume of solute per volume of solution times 100, or a combination, mass of solute per volume of solution times 100, or volume of solute per mass of solution times 100. Kapag ppm, it has to be multiplied by 10 to the 6. At kapag ppb, by 10 to the 9th. Now, molarity. Okay, the definition is number of moles of solute dissolved in 1 liter of solution. So M represent big letter M to represent molarity. This is the formula, moles of solute per liter of solution, meaning liter of solution, the solute and the solvent are together in that solution, in that particular volume of solution. Okay, so this is how you prepare it. You have the measured mass, the required mass, you measure it. The volumetric flask already holds a solvent, as partially filled with solvent. Then you add the solute, you shake them together, and then eventually you add more solvent up to the mark. Okay, so if this is a 1000 ml volumetric flask, you will fill this up to the line representing 1000 ml. So yung 1000 ml, you have the solute and the solvent together. Determine the molality and molarity of a solution of sodium chloride prepared by adding 37.6 grams of solid sodium chloride to 150 grams of water. The density of the saline solution is 1.1478 grams per ml. We need to find the molecular weight. You can always find this in literature, and it is 58.44. Let's start with molality first. Okay, it is expressed in mole of solute per kilogram of solvent. So what do we need to do? We convert 37.6 grams of sodium chloride to mole of sodium chloride. Okay, so what do? We divide it by its molecular weight. And of course, itong 150 grams of water, kasi ito yung solvent, grams ito, so we need to convert it to kilogram of solvent. Okay, so 37.6 grams of sodium chloride divided by its molecular weight, which is 58.44 grams per mole, will convert 37.6 grams of sodium chloride to mole of sodium chloride. Yung gram will cancel out. Yung mole pupunta sa numerator. And when you convert 150 grams of water to kilograms, you simply divide it divide this by 1,000 grams per kilogram. So, magiging 0.150 kilograms. So, mole per kilogram na siya. And so, your molality is 4.289 molal. Sa molarity naman, ang units ay mole of solute per volume in liter of solution. We can also express this in millimole of solute per volume in milliliter of solution. Gagamitin ko itong expression na to, yung millimole per milliliter, dahil ang density na given sa atin is already in milliliter. Okay, we need to remember that the mass of the solution consists of the mass of sodium chloride plus the mass of water. And the ratio of sodium chloride to total mass is 37.6 over the total weight of the solution, which is 187.6. That will give me a ratio of 0.2. If I multiply this by 100, I will have 20%. Ibig sabihin, yung resulting solution ng 37.6 grams ng sodium chloride at 150 grams of water is 20% sodium chloride. Now, punta tayo sa density. Ano bang may extract natin sa density? 1.1478 grams per ml of solution. Okay, ibig sabihin, yung mass na to, 1.1478, consists of the mass of sodium chloride and the mass of water together for every ml of solution. Yan ang ibig sabihin ng density. Okay. Now, we know earlier that ang solution is 20% sodium chloride. So, if I multiply this by the ratio of sodium chloride to total mass, okay, etong gram sodium chloride plus water and gram sodium chloride plus water maka-cancel out. At ang maiiwan ay gram of sodium chloride per ml of solution. Okay? So, malapit na tayo kasi grams per ml. Okay? Ito, millimole of solute per ml of solution. Nasa grams na tayo. So, anong gagawin natin dito? We convert grams of sodium chloride to millimole of sodium chloride para maging millimole per ml. Okay. So, if you plug all these values into your calculator, you will end up with 0.23 grams of sodium chloride per ml solution. Okay? So, we need to factor this, we need to introduce another factor so that we get rid of gram of sodium chloride at mapapalitan siya ng millimole of sodium chloride. So, paano gagawin? We multiply this by milligram per gram. Okay? So, i-convert ko yung gram to milligram. Okay? Paano ba? Ang 1 gram is 1,000 milligrams. So, if I multiply this by 1,000 milligram per gram, I will get rid of the gram unit. Okay. What else do we need? I need to convert a milligram of sodium chloride to millimole. Okay? So, I divide it by its molecular weight in milligrams per millimole. Okay? So, balikan natin. Alin ang magka-cancel? Gram and gram. Milligram and milligram. Millimole pupunta sa itaas, sa numerator. At ang naiwan ay millimole per ml. Okay. Which is the unit of molarity. So, molar concentration is 3.936 millimole per ml solution.